Hello viewers, welcome to my channel. If you haven't yet subscribed to my channel, do subscribe and press the bell icon near the subscribe button so that you get the notifications of my latest videos, and do not forget to like and share the video. Now we'll be solving all the questions from this chapter, light, reflection and refraction. First we'll be going on with all the in-text questions. After we have completed the in-text questions, we'll move on to the exercises. So first I'm going to solve the questions on page 168. We have 4 questions. The first question is, define the principal focus of a concave mirror. About which spherical mirror are we talking about? We are talking about the concave mirror, and we are asked to define the principal focus of the concave mirror. So first you should know the concept. What is principal focus of a concave mirror? First let me explain you the concept. Then I'll move on to the definition of principal focus of this concave mirror. So first let me take a concave mirror. This is the concave mirror, and this is the pole. Then this is center of curvature. Alright, now I'll not tell you where is the principal focus, I'll just show you. And I draw my principal axis. A number of rays parallel to this principal axis. Okay, let me take my object somewhere at infinity. And a number of rays parallel to this principal axis incident on the concave mirror. Alright. And after reflection, this ray goes something like this. This is the reflector ray. Another reflector ray from here goes like this. This gets reflected back like this, and this incident ray gets reflected back like this. They all meet at a point. This point is the principal focus, capital F. Now how would you define the principal focus of the concave mirror? You would say that a number of rays parallel to the principal axis incident on a concave mirror, and after reflection meet at a point. This point is the principal focus of a concave mirror. If necessary, draw the diagram also so that you can impress your evaluator, the person who is going to correct your paper. Alright, now we move on to the second question on page 168. Here we'll be applying a formula, a very important and simple formula. The question is, the radius of curvature of a spherical mirror is 20 centimeter. What is its focal length? The radius of curvature R is 20 centimeter. Which spherical mirror? It's not mentioned, so don't bother about that. Just see the question properly. The radius of curvature is 20 centimeter. And what we have to find? We have to find the focal length of that spherical mirror. So I write whatever is given. Radius of curvature is equal to 20 centimeter. Now we know that radius of curvature, there's a relationship between R and F. We all know that. So radius of curvature is equal to twice the focal length. Just substitute the values. So therefore this implies F will be equal to R upon 2, or half of radius of curvature is your focal length. Now this implies focal length is, what is R? Put the value, 20 by 2 is equal to 10 centimeter. Therefore the focal length of that spherical mirror is 20 centimeter. Just conclude your answer and you're done. Now we move on to our third question on page 168. For this you should remember the ray diagrams which you studied. The question is, name a mirror that can give an erect and enlarged image of an object. Alright, this is the question. Now when you recall all the ray diagrams, we have studied the ray diagrams for convex and concave mirrors, and we know the characteristics of images formed by plane mirror also. Now you see the question, your question is in the given part itself, you can see a word is used, erect. So erect itself shows that a word called virtual will definitely be there. Somewhere it's hidden. If there's a word real, then the word inverted is hidden. If there's a word virtual, then erect is hidden. Because virtual and erect are always together, real and inverted are always together. Since the word erect is given, you can easily understand that you get a virtual image from that mirror. Now the question is erect and enlarged. So recall all the mirrors, or all the characteristics of the images of all the mirrors that you studied. First we studied about plane mirror. Plane mirror. So plane mirror always forms a virtual and erect image. But what kind of virtual and erect image does it form? Of the same size. Same size. Then concave mirror. Going to the spherical mirrors, we have concave and convex mirrors. Concave mirror. Remember the ray diagrams. In one of the ray diagrams, we saw that virtual and erect image is formed. What kind of virtual and erect image? It was enlarged. Now recall convex mirror ray diagrams. Convex mirror. This is just for your understanding. Convex mirror always forms virtual and erect image. But what kind of virtual and erect image? Diminished or highly diminished. Smaller size, okay? Either diminished or highly diminished. Now you compare all the three. You see over here same size, enlarged, diminished or highly diminished. What is asked? What do we want? Erect and enlarged image. Enlarged. The main thing is here, because all of these are erect, because they are virtual and erect. But we need enlarged. Do we have enlarged over here? No. Do we have enlarged over here? No. We have enlarged over here. So our final answer to this question is concave mirror. Only one word. But you should remember all these things and all the ray diagrams that you studied. Now to the fourth and final question we move on. On page 168. A very simple question related to our daily life. Why do we prefer convex mirror as a rear view mirror in vehicles? This is your question. You might have observed in all the vehicles you have a side mirror, a wing mirror. That is your rear view mirror. And we have studied in the applications of convex mirrors that convex mirrors are generally used for rear view mirrors. They are used as rear view mirrors. Now the question comes, why not any other mirror? Why do we prefer only convex mirror? It is very easy. The answer is very easy. The convex mirrors are always preferred because they give virtual and erect image of the object, plus very important, they give a diminished view of the vehicles that come behind them, and this enables a wider field of view to the driver who is driving, and this prevents accidents. Because of this reason, we use convex mirrors as rear view mirrors in vehicles, not any other mirror. Because if we use concave mirrors, they'll give enlarged image of the object and we won't be able to see anything clearly. If we use plane mirror, it'll give the same size of the object, but in convex mirrors it gives a wider field of view since the size of the image is diminished. So that's it. We have completed the questions on page 168. If you have any doubts, ask me in the comment section, or if you want me to make any video from any topic, from any subject, just mention in the comment section.